This question is from an M1 paper, which would be equivalent to AS2, and it's a mechanics question. It says, the figure below shows a skier of mass 78 kilograms being pulled up a smooth slope by a rope. The slope is inclined at an angle of 20 degrees to the horizontal. The rope is inclined at an angle of 60 degrees to the slope. And it says, draw a diagram showing all the external forces acting on the skier. Okay, so first of all, you've got the weight of the skier, and it's acting vertically down. So it's acting just straight down. There we have it. And its weight is, his mass, is 78. So his weight is 78g going vertically down. And then you can mark on this wee angle in here is 20 degrees. And then you've also got the normal reaction. I'm just doing it through his head. It is at R, and it's being pulled. There's a tension in the rope, and that is acting at 60 degrees to the slope. So that's everything that you have got. Okay. Next question says the skier is moving at a constant speed of 2 meters per second. So I'm just going to mark that on just a single-headed arrow, 2 meters per second. A single-headed arrow as opposed to a double-headed arrow. Double-headed arrow I use to denote acceleration. So single-headed just means there is just a constant speed. So if you're moving at a constant speed, that means the force up the slope is equal to the force down the slope. It says find the tension in the rope. Okay, so we'll do that up here where I've got my diagram. To find the tension in the rope, I'm going to just resolve parallel to your plane, and there's no F equals ma. So going up the slope, if you can imagine here, going up the slope, what I have got, I've got a certain amount of force going up this way through the tension in the rope, and down the slope, the only thing I've got is a component of the weight. Okay, so it's not clear, but that was at 20 degrees. So this is 20 degrees we're going to have to do. So I'm going to draw my diagram again to make it a wee bit more obvious here. Bear with me a wee second. Draw my diagram. So there is the skier. They were 78 kilograms, so 78 G newtons. It was at 20 degrees. I know that doesn't look like 20 degrees, but it just makes it a lot easier to draw this. And then up the slope, you had your tension in your rope. That's T, and that was 60 degrees to the incline of the slope. And then you had your normal reaction as well. Don't know if we need to find the normal reaction. Okay, so we'll just do this again here. It's a wee bit clearer. We're going to resolve parallel to your plane. And again, the force up the slope, which is T, cos 60, is equal to the force down the slope. So down the slope, you had the component of the weight going that way. Up the slope, you had the component of the tension going that way. So down the slope, you just have 78. You just have 78 G sine 20, which means T itself is going to be 78, and I haven't used my calculator at all yet. 78 sine 20 divided by cos of 60, and just file that all into your calculator. Make sure your calculator is in the correct mode, so it has to be in degrees mode in this case. So top line of my fraction, I've got 78 times G, which we're assuming is 9.8, times sine of 20. Bottom line of my fraction, I just have cos of 60, and press equals, and when I did that, I got my tension to be 522.88. We'll go for 0. I'll just show the whole thing, 3951, just in case we need that later on in the question. But my tension is 522.88 newtons to 2 decimal place. I'm not too sure what the degree of accuracy was. Don't think it said. There, find the tension in the rope. Okay, next one, it says, when a skier is 26 meters from the bottom of the slope, she lets go of the rope. Find the speed of the skier when she reaches the bottom of the slope. Okay, right. Let's do a new diagram. So the mass of this skier hasn't changed. She's still on this 20 degree slope. Her mass then is still, as we said, it was still 78. So that's G newtons is her weight. That's still 20 degrees. She still has a normal reaction, and there is no tension. So she's not holding on to this rope, so there is no tension, so we can forget about it. So for this bit, we need to find her acceleration. So she's going to start going down the way. She's going to be accelerating this way. Okay, that's what we need to find. So it's now an F equals ma question. So force equals mass times acceleration. What I'm doing, I'm resolving parallel to my plane, and I'm using force equals ma. And your force down your plane is a component of the weight going this way. So the component of the weight going this way. So that means down the plane, you've got 78g sine 20. Sine 20, remember, because we don't have the angle. That equals my mass, which is 78 times my acceleration. You can notice there you can divide across by your 78, which will leave your A. A is just equal to g times sine of 20. And you could work that out if you wanted to. I don't think I'm going to bother. I'm just going to leave it as it is. It then becomes a SUVAT question. So, if you consider, I'm going to use SUVAT, and I'm considering anything going up the slope as being negative. Okay, so anything going up the slope as being negative. So she initially was going along at a speed of 26 up the slope, but I've just said, remember, that's negative. So we have to make that a minus 26. So anything going up the slope is negative. So that means it's minus 26. She's accelerating down the slope. She's accelerating down the slope. So that down the slope then, the acceleration is going to be positive g sine 20. The distance she is from the bottom of the slope is 26 meters? Oh, I've got that wrong. Sorry, it was 26 meters is the distance down the slope. She was going at a speed of 2 meters per second. Apologies, it was 2 meters per second. So that should have been, she was going up the slope with a speed of 2. So that then should be just minus 2. And what we need to find is find the speed of the skier at the bottom. So we want to find our v. So that's what we're looking for here. Okay, so let's get on with that then. So it's just a SUVAT question, as quite often they're built into it. So you've got your v squared equals u squared plus 2as, and then that means your v squared is equal to minus 2 squared plus 2 times my a, which is g sine 20, times my s, which is 26. So let's just work that out and find a value for my g. So that's 2 times 9.8 times sine of 20, and then times 26. And that works out as 178.29 ... My v then, square root that thing and see what I get. And I got 13.35 meters per second. And that was the 2 decimal places. Keep watching if you want to see a different way of setting this out. Okay. So another way you could have done this question, which is probably the way I would do it more often than not, to be honest, is I know it's moving, it's starting off and it's moving this way at the start. So, but this will work out as a negative acceleration. So this is where you consider anything moving up as positive. So here, my r is going that way. My weight, 78g, is going down still. I've still got my 20 degrees here, and that is it. So I was moving initially with a speed, remember, of 2 meters per second upwards. I'm going to resolve parallel to your plane, and I'm going to use F equals ma. So same idea. It's going to be up the plane then, it's minus 78g sine 20 is equal to my mass, which is 78 times a. And then this time you get your a is minus g sine 20. Okay, now we're going to use SUVAT, and I'm considering anything going up the plane as positive. So initially I started, my u was 2. My a then is minus g sine 20. My s was 20 minus 26, because I have to go 26 meters down the slope. So I'll make that minus 26. And v then is what I want to find. So again, it's v squared equals u squared plus 2as, which is v squared is equal to 2 squared plus 2 times the minus g sine 20 times ES, which is minus 26. That's going to give you the same thing, 178.29. So v squared is equal to 178.29 dot dot dot, and then your v, your speed, then is equal to, again, 13.35. We're looking for speed, so we don't have to worry about it being the negative one, and that's us. So there's just another way to do the same part of the question. So very common for a F equals MA question to then lead into SUBAT.